Welcome back everybody. So we are looking at grade 5 module 1 topic A. We're going to look at the first 4 lessons in module 1 and go over problems that hopefully help you succeed on this module A quiz. All right, so let's take a look here. First lesson, lesson 1. So we were to reason concretely and pictorially using place value understanding to relate adjacent base 10 units from millions to thousandths. Now remember, we're talking about thousandths, so we're talking about that THS, don't forget that. So not thousands, but thousandths. The directions say, use the place value chart and arrows to show how the values of each digit changes. The first thing we do, we talked about the 3 steps that we need to do when we are solving these types of problems, when our second factor is a base 10 unit. In this case, our second factor is 100. So the first thing we're going to do is we're going to write our first factor on the place value chart. So we have 6 and decimal says and 671 thousandths. Then we're going to say, well, okay, our operation is multiplication. So we know that our digits are going to be moving to the left. So arrow to the left. How many times? Well, we count our zeros. 2 zeros in 100, that means we're going to move 2 place value units. Our 6 ones times 10 is going to be 6 tens, times another 10 is 6 hundreds. So we have 6 hundreds, 6 tenths times 10 is 6 ones, times another 10 is 6 tens. So we have 6 tens, and then we have 7 hundredths times 10 is 7 tenths, times another 10 would be 7 ones. And of course, last but not least, 1,000th times 10 is 100th, times another 10 is 1/10. And our answer is going to be 667 and 1/10. All right. B, 684 using division. So we're divided by 1,000. Same situation. We're going to write our whole in the place value chart up top. 6 hundreds, 8 tens, 4 ones, divided by 1,000. Well, we know that 1,000 has 3 zeros, so we're going to make 1, 2, 3 jumps to the right. So we know this 4 is going to move divided by 10, divided by another 10, which is divided by 100, divided by another 10, which is the same as divided by 1,000. So every time we move, we divide by 10. That's another 10 and another 10. So 4 ones divided by 1,000 is going to be 4 thousandths. Then we have 8 tens divided by 1,000. It's going to be 8 hundredths. And last but not least, 6 hundredths divided by 1,000. 1, 2, 3 adjacent base 10 units. It's going to be 6 tenths. I like to put my 0 in my ones place just to show that I don't have any ones, but that's our answer, 684 thousandths. I want you to pay attention to the difference between lesson 1, where we are reasoning concretely using our place value chart and using pictures on the place value chart, versus lesson 2, where our objective is we're going to reason abstractly using the place value understanding to relate adjacent base 10 units from millions to thousandths. So now, instead of drawing my place value chart and showing those moves, I'm going to use my understanding. Lesson 2 is abstractly using my thinking in my head. So we have 32 and 1/10 times 10. I know since we're multiplying, my digits in 32 and 1/10 is going to be moving to the left. So in my mind, I'm going to say 32 and 1/10. If every digit moved 1 place, because I have 1 0 and 10, 1 place to the left, my 3 tens is going to become 3 hundredths. My 2 ones is going to become 2 tens, and my 1/10 is going to become 1 1. So my answer would be 321. All right, let's look at B here. I'm going to try to do the same thing, but without my place value chart. So now I have 3,000, we'll put a comma there, 3,632 and 1/10. I know I'm dividing by 10, so I'm moving to the right one time. That means that my 1 that was in the 10th place is going to move over one place value unit to the 100th place. My 2 that was in the 1's place is going to move over to the right one place value unit to the 10th place. And my 3 that was in my 10's place is going to move to my 1's place. My 6 that was in my 100's place is going to move over to the right to my 10's place. And my 3 that was in the 1,000's place is going to move over one place value unit to the 100th place. So my answer would be 363 and, decimal says and, 21/100ths. All right, picking up the pace here. I know that I'm multiplying, so the 455 is going to move over one place to the left. That's an arrow. Not one place, but 1, 2, 3 places. I'm multiplying by 1,000. My 455 is going to move 1, 2, 3 places and become 455,000. So now this 5 that's in the 1's place is going to make jumps. We should be doing this abstractly. Put more place values than I needed. But this is going to go 1, 2, 3 places over. So my 1's place divided by 10, divided by 100, divided by 1,000. That 5 1's becomes 5 thousandths. My 5 10's becomes 5 hundredths. And my 4 hundreds becomes 4 tenths. And then my answer would be 455. What place value is that 5 in? Hopefully you said 1,000. All right. Now, if you notice, lesson 1 was concretely, we were drawing pictures. Lesson 2 is abstractly, we're slowly climbing up the staircase. Now we're moving on to lesson 3. Lesson 3 says we're going to use exponents to name place value units and explain patterns in the placement of the decimal point. So this is key to understanding and making this a little more easy to do. So now we say, write the following in exponential form and as a multiplication sentence using only 10 as a factor. So we can only use 10 as a factor. They give us an example. 100 is equal to 10 to the second power, which equals 10 times 10. Same thing. We know that we have 3 zeros there, 2 zeros there, 2 zeros there. So for A, I have 1,000. I know that 1,000 is equal to 10 to what power? Hopefully you said 3, 10 to the third power. So therefore, I'm going to say 10 times 10 times 10. If you didn't do this already, push pause and try to solve B. Hopefully you said that 100 is equal to 10 to the second power, and another 100 will be 10 to the second power. So we have 4 zeros, which would give us 10 to the fourth power, or 10 times 10 for my 100 times another 10 times another 10. So that would be 1, 2, 3, 4 tens, which would give us 10,000. That's the answer. We didn't need this. I just gave us that as a bonus. All right. So it says, write the following in standard form. Standard form, they want that answer, the final answer. All right. So now we're going to say 3 times 10 to the second power. Well, I know here that 10 to the second power is equal to 100. So what is 3 times 100? Hopefully you said 300. All right. Now for B, well, we're not multiplying by a whole number. If you notice 3, we didn't have a decimal point or anything after the decimal point. For B, it's 2 wholes and 16 hundredths. So 2 and 16 hundredths times 10 to the fourth power. I'm going to say it might be easier for you to do this right here and say, well, 2, 3, 4. Well, I know if I had my 2 and 1600ths on a place value chart, and I multiplied it by 10,000, well, I would move over 1, 2, 3, 4 place value units. That would be my 2 would be there, 1 here, 6, fill in my zeros, and then I can say, okay, there's my comma. That would be 21,600. All right. Same thing. If you're talking about this part where we're talking about the end of the objective, which was placement of the decimal point, in my mind, I look at this. I'm still looking at B here. Let's change it to green. I'm still looking at B. So when I see 2 and 1600ths, and I know I have to move 4 times, I make it look like the decimal's moving. But what's really moving is the digits. It's not the decimal point that's moving. It's the digits that's moving, and it causes the decimal to appear to move. Similar to, I always make the reference or the analogy of the sun. We know that the sun appears to move. The sun appears to move across the sky. You might say, well, no, when I woke up, it was on this side of the sky and it moved to the other side of the sky. What we really know, and we learned in 5th grade, or many of you learned before 5th grade, is that it's not the sun that's moving, but it's the planet Earth that's rotating on its axis. Similar to that, it may look like the decimal's moving, but the decimal doesn't move when I do this. So pay attention. Said all that to say this. So when I multiply times 10 times 100 times 1,000 times 10,000, put my zeros in. Now my new number is going to have a decimal there. This decimal is going to be gone. I have the 21600. That's how you are going to use the placement of the decimal to understand the movement of your digits. The digits move, not the decimal. All right. That's why in class we use the place value chart that's taped down to our desk, and we have a clear sheet of paper that we move our transparency with the numbers on it. All right. So we're going to work through C and D using the placement of the decimal that appears to be the movement of the decimal. Decimals don't move. All right. So we have 800. If I had 800, my decimal would be right after the second zero. I'm dividing by 10 to the 3rd power, which is equivalent to dividing by 10 times 10 times 10. Every movement is going to be an adjacent movement of the digits. So divided by 10, divided by 10, divided by 10. That's 3 moves. Now my decimal is going to appear to have moved to in front of the 8. So I would have 0 and 8 tenths, or 800 divided by 1,000 is going to be 8 tenths. So we have 800. Remember, the decimal's not going to move. What's going to happen is the digits in 800 are going to move. So this, we're dividing by 10, 100, 1,000. So this 0 is going to move to this slot, which is my thousands place. This 0 that's in my tens place is going to move to my hundreds place, and my 8 that's in my hundreds place is going to move to my tenths place. Same thing I did here, but it made it look like the decimal moved in the opposite direction, but it really was the number moving. This 800 moved on the place value chart. Okay, so keep that in mind when we're talking about the placement of the decimal. Show you again with D. So if I'm dividing by 10 to the 2nd power, that's like dividing by 100. I know that division, the number is going to move to the right. The digits in 754 are going to move to the right. My 2 that's in my tenths place is going to move to my hundredths and then my thousandths. My 4 that's in my ones place is going to move to my tenths and then my hundredths. My 5 that's in my tens place is going to move to my ones and then my tenths, causing my decimal to be here. And then my 7 that's in my hundreds place is going to move 2 places and end up in my ones. Let's look at that on the place value chart. So we have 7, 5, 4, decimal 2. Watch my 2. We move from my tenths place, 1, 2, over to my thousands place. then my 4 ones moved tenths, hundredths, my 5 tens, ones, tenths, and finally my 7 hundredths, tens, ones. So it appears like what I would have done if I was just solving this on my own without trying to teach this, I would have just made it appear like my decimal moved 1, 2 places, and my decimal is going to appear to have moved between my 5 and my 7. Also my 7 to be in the ones place. All right, last but not least, lesson 4 already. How time flies when you're having fun. Okay, so we're using exponents to denote powers of 10 with application to metric conversions. All right, so we're talking about metric conversions. So with the metric system, we're talking about kilometers, meters, centimeters, and millimeters. All right. Now, of course, we know, we talked about this in class with the meter stick. We know that 1 meter is equal to blank centimeters. Somebody go ahead and fill that in for me. Thank you. Hopefully you said 100 centimeters. All right. We know that 1 meter is equal to blank millimeters. Hopefully you said milli or milli, 1,000. Centi, think of cent. Centimeter, think of cents. 100 cents or 100 pennies equals $1. All right. Let's go ahead and convert. Well, we know if we know that 1 meter is equal to 100 centimeters, then 2 meters is equal to blank centimeters. So we know that that's going to be, hopefully you said 200. All right. And it's asking us to use an equation with an exponent. So we say that 2 meters times 10 to the second power equals 200. You say, well, how'd you get 10 to the second power? What did I have to multiply 2 by to get to 200? I had to multiply it by 100. Well, 10 to the second power is equal to 10 times 10, which equals 100. All right. So now we're going to divide by 1,000 because we're going from smaller units to larger units. We know that if it takes 1,000 millimeters to equal 1 meter, then we know that 40 millimeters is going to be less than 1 meter. So we're going to divide by 1,000. So we would say 40 divided by 1,000. It's 40 divided by 1,000 as 10 to the third power. So if we had 40 on our place value chart, and we divide it by 10, divided by 10, divided by 10, we would end up with 4 hundredths. Everybody see that? Divided by 10, divided by 10, divided by 10. So we're going to end up with 4 hundredths of a meter. All right, so number 2, read each aloud as you write equivalent measures. So a piece of fabric measures 3.9 meters. Express it as centimeters. So we're going to express the length as centimeters. We're going from meters to centimeters. So we're going from larger units. Remember, 1 meter is 100 centimeters. So we know 3 meters is going to be 300 centimeters. But now we have 300 and what? Because we're almost at 4. Let's go ahead and write it on the place value chart. So we had to multiply by 100. We know that 3 times 10 times 10 is going to be 300. And then we say, well, 9 tenths times 10 times 10 is 90. So we know it's going to be 390 centimeters. The 0 was a placeholder. So don't forget your units. We can put 390 centimeters. Also, we could have done 3.9 times 10 to the second power is equal to 1, 2, 390 and centimeters. All right, Mr. Ramo's thumb measures 4 centimeters. Express the length in meters. Wow, so we're talking about a thumb. Now we're talking about the metric system. So we're talking about centimeters and trying to express them as meters. We're going from a smaller unit, centimeters to a larger unit. So when we go from smaller to larger, we know we have to divide. So we're going to say 4 centimeters divided by centimeters to meters. That's centimeters to meters is 100. We could have wrote that as 10 to the second power. And we're going to say this is equal to divided by 10 divided by 100. It's going to be equal to 4 hundredths of a meter. All right. So we know we could have looked at that on the place value chart as well and said, well, we have 4 divided by 10, or decimal divided by 100, we get 4 hundredths. All right, that is it for lessons 1 through 4. Topic A, multiplicative patterns on a place value chart. All right, boys and girls, I hope this helped you. Look for more topic videos coming out soon. Hopefully you are locked in and ready for this quiz.